All right, folks, here we are in part 2 of our confusion matrix how-to, just following along with the book. This is for where we're calculating our Kappa coefficient, and this is Kappa gives us an insight into our classification scheme and whether or not we achieve results better than we would have achieved strictly by chance. You can see Kappa's formula here, and we'll get to that in a second, but we'll start by calculating this expected, so we already have observed, right? Sorry, we don't have observed yet. We're just going to start by calculating expected by multiplying the rows and the column totals. So what does that mean? So we are going to calculate. It helps actually if you go back to the page in the textbook that the original confusion matrix is on, which is in, it's a lot smaller so I can see it. So it's on page 307, 397, sorry about that, 397. And then the calculation about how they work through it is on the other page, but let me just show you the book for a second. So we're going to see this in a second, but it's the product of the columns and the rows. So you'll be multiplying the totals. Well, let me just show it to you because I'm bad at explaining. Actually, let's do it this way. Let me erase that. So let's take a look at their confusion matrix, and we'll walk through. I'm on page 398 on my other screen, so I'm going to kind of read through this Kappa. It says, first you calculate the product of the rows and the columns. So basically, you're multiplying for this area here, for this part of our confusion matrix, you are multiplying, let me change the pen, the product of the row times the column. So that's why in the book it says this one up here is 0 times 1. 0, sorry, 1. And for this row here, it's 0 times 21. So 0 times 21, 0 times 72, 0 times 6. For this last category over here is 0 times 6. And so that's the sort of pattern you're doing. You're going for each row. Let me change my pen again. For this row here, for this square, we're going total of the column times total of the row. So actually going total of the row times total of the column. So 9 times 1 will fill in here. 9 times 21 we fill in here. 9 times 72, etc. And you'll go through again 67 times 1, 67 times 21, etc., etc. So what does that look like on our confusion matrix? So what I did, again, so their values are slightly different. Let me scooch this out of the way. What I'll do for you is you'll have this we'll just put this right over here. Paste that in. Okay. Let me scooch over just a little bit. So I'm going to make sure, did I paste just the values? Let me redo that actually. We just want to paste the values in. So you won't have, and this one won't be, any of your formulas will be slightly labeled, slightly different. But so here for this class, we're now doing some of the product, or the sum of, or the product of the row times the product of the column. What did I do wrong? What is that saying now? Circular dependency detected result. Wow, spread. Oh gosh. Okay. So I fixed this, so let's try that again. So we are multiplying this, oops, not plus, times this. And then we'll do the same, we'll do this times the 35. So we'll do, and then 2 times 43, 2 times 21. Okay. So you'll do that for all the rows. You can just, again, we're going equals 29 times 1 equals 29 times 35. Anyway, so on and so forth. I'm going to pause it and do this math real quick. All right, all that is calculated. So then we are going, so now I'm on page 399, and it says use to, everything highlighted. Oops, this one should not be highlighted. Let's clear that. Everything highlighted is used to calculate product matrix. So then we calculate what would be expected based on chance. And you see in the book on 399, product matrix divided by the cumulative sum of the product matrix. So we'll have something here that's product matrix. And we'll say that this is equal to the sum of the diagonals. So it's plus, 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 enter. And then we have our cumulative sum, which is just everything in here, all these other values. All the other values? I'll go back and check. 0, 0, 4, 0. Yep. So then it's the sum of everything. So let me add, it's going to be everything in this box. So all right, so for us that equaled 10,000, or for me that equaled 10,000. Okay, so then we do our product matrix divided by the cumulative sum. So this is our expected. All right, so now we get to calculate that Kappa score, which I'm moving this again, because it's to my way again. All right, so there's our expected. Let's calculate, we'll calculate Kappa now. So Kappa is our, let's scooch back, our overall accuracy. We have to put parentheses around this. Our overall accuracy minus our expected. Divided by 1 minus our which one? 0.317. Okay, and then we multiply that times 100, get our Kappa percent, so almost 70% is what I'm looking at. So the Kappa coefficient for my unclassified output in and around the Fresno area is about 70%, which means, it's about it's 0.6925, so about 70%, which means that the classification is almost 70% better than would have been if it occurred strictly to chance. This is really where you can stop. It asks you to calculate your overall accuracy and Kappa for your supervised image. So you could go through and do that again. And then I'll have a video showing you another option.